Now we need to find the angle of the throw. So when I threw the discus, my arm was like this, and that line represents the hypotenuse. And this angle equals theta. So that's what we want to find. When these two lines intersect, the vertical and the horizontal line, they make a perpendicular angle, which is 90 degrees, leaving us with each of these other angles being 45 degrees each. So 90 plus 45 plus 45 equals 180. 180 degrees equals that of a triangle. So theta in this type of equation will equal 45 degrees. These are our two equations so far. X equaling velocity times cosine theta times time. So now we know that theta equals 45 degrees. And x equals velocity cosine 45 times t. Now for our vertical axis, we have y equaling velocity sine theta times time minus half gravity times squared. So then we just plug in 45 degrees for theta, and our equation is y equals velocity times sine 45 times time minus half of gravity times squared. Now we need to find time. We'll do that by simply timing the time we got from the video. Now we need to find some missing variables. First, we are going to find time. Well, that's easy because when we threw the discus, I had my sister time the time it was in the air, which was 4 seconds. Now it's time to add time to both of the equations. X is going to equal velocity cosine 45 times time, so then we plug 4 in for t, and we get x equal to velocity cosine 45 times 4. For the vertical axis, we need to plug in 4 for time again, and then we're going to try to find the max height while using this equation. So y is going to equal velocity cosine 45 times t minus half gravity t squared. So now we plug in the numbers. Y is going to equal velocity cosine 45 times 4, which was the time, and subtract half gravity times 2 squared. We do 2 squared because at the max height, it's half of the time that's in the air. So 4 divided by 2 is 2. So 2 squared equals 4. And gravity is going to equal 16 because 32 divided by 2 is 16. So our new equation will be y equal to 4 times velocity cosine 45 minus 16 times 4. The velocity for this particular throw was 37 feet per second. So now we need to add the velocity into the equation. So now we have, for the horizontal equation, we have x equaling 4 times velocity cosine 45. Now we plug in 37, and we get x to equal 4 times 37 cosine 45. So then we just plug and chug. We plug 4 times 37 times cosine 45 into our calculator, and you get 104.65, which is approximately 104 feet 7 inches. Now it's time to find the max height. We plug in 37 for velocity for this equation also. So y is going to equal 4 times 37 sine 45 minus half gravity 2 squared. So y is going to equal 4 times 37 sine 45 minus 16 times 4. When you plug this in your calculator, you get approximately 40 feet 6 inches, 7 inches, if you're going by sig figs. So that means when the discus is at its maximum height, it is about 40 feet 7 inches above the ground. So what does this mean? Well, after 4 seconds, the discus has traveled about 104 feet 7 inches. So if I'm standing here and we throw the discus, here's the landing, and that will give us the total distance of which I threw the discus, which was 104 feet 7 inches. And we use this equation to get that total. Now for the y, we use y to find the max height in the air. Hence, it's vertical, so that's all we could really use to find. So y is going to equal 4 times 37 sine 45 minus 16 2 squared. And we get 40 feet 7 inches. Now I could have changed 2 and made it like 3 seconds, but that would have made it like not the max height. It would have been probably over here in the middle between 2 seconds and 4 seconds. So you can plug any time in for the equation to find how high it was in the air at a certain time. These equations help you find how far you threw the discus, and you can manipulate these equations to find certain parts of it. Like say if I already knew what x was, I could manipulate the equation and try to find what the degree I threw it, and I'd have the time and the velocity. Now I could do that the same way if I wanted just to find time. If I knew it was 104 feet 7 inches, I could just leave time as a variable, and I would know it was 37 velocity and my angle was 45 degrees. So you can use these equations in many different ways. I'm just showing you how far I threw the discus and what the max height was.